So in this final video, I wanted to introduce and mention how to use REFPROP to simulate CO2. So the first thing you want to do is install REFPROP, and on your CERN desktop, you'll go on the bottom right here and right click on this icon. Here you can add and remove packages to your CERN desktop. REFPROP is called NIST REFPROP. And you can go ahead and click here to install. So this is the homepage of REFPROP. Once again, REFPROP is a collection of thermodynamic properties of different refrigerants. So the first thing you want to do is choose your substance, which we'll choose as CO2 or carbon dioxide. Then we can also use some relevant units. So we'll choose SI with Celsius and also change the pressure to bar. Now we can do many useful things. The first being calculating a pH diagram. So here we can change the parameters, and now we're going to be plotting temperature isotherms as well as vapor quality lines. So for instance, here are the isotherm for minus 30 degrees Celsius, and here are the vapor quality lines. If you hold shift, you get these crosshairs, which you can use to select specified state points. For instance, on the top left here, you can see the state points. There's also more useful things you could try. For instance, calculating saturation tables, isoproperty tables, or phase boundaries. We can also calculate fluid properties at specified state points. For instance, here we'll try CO2 at minus 40 degrees Celsius and 5 bar to determine the density. So finally, I want to introduce CoolProp, which is a Python package which extracts thermodynamic properties from REFPROP. This is very useful in case you wanted to simulate CO2 flow. So on CoolProp here, there's the props SI function, which you can use to extract all the following inputs of CO2 based on specified state points. So in this Jupyter notebook here, I'm simulating two-phase, single-phase, pressure, and temperature. So here is how I import the Python library CoolProp, and here are the correlations I've used in case you're interested in repeating the simulation. So for example, here I simulate the pressure and temperature profile over the Longeron mockup for the Atlas ITK. I'm initializing the simulation by defining the inlet temperature and inlet pressure. So as you can see here, I'm simulating fluid, wall, and saturation temperature, as well as pressure and vapor quality. On the other hand, we can also simulate or compute a pH diagram. So here, I'm using experimental points to plot the pH diagram for the warm nose off and warm nose on. As we saw previously, the warm nose on increases the enthalpy of the CO2 before the capillary. So that concludes this YouTube series. I hope you learned something, and feel free to reach out to me in case you have any further questions.